the earthquake waves will move in all direction, and the first one to reach on the surface, it will be exactly above the focus. It is called as epicenter of earthquake. Richter scale calculates the magnitude of the earthquake. Okay, magnitude, and it is logarithmic scale. It is logarithmic. Now, what do you mean by logarithmic? What is the significance of logarithmic scale? Beyond that, S waves are not detected. So, this is the larger area. Rather, it is considered that 40% of Earth's surface is, let's say, shadow zone of S waves. 40% of Earth's surface. Okay, have you all attended the orientation session? Saturday? On last Saturday we had orientation session also. Alright, so first we will start with geography. You all have PGP booklet, schedule. Schedule है आपके पास, सबके पास? Okay, some students may be new students. ठीक है, आप PGP schedule दे दीजिएगा, ठीक है, print करके सबको. Alright, so you can see that we have integrated the classroom learning with test series. Okay, this is the complete plan for PGP for your prelims preparation, and there will be around 4 to 5 classes during the weekdays, and during weekend there will be test. Also, you will have practice MCQs at the end of each session, classroom session, where the faculty itself will be taking solving those MCQs with you. So, that is a kind of live practice of MCQs based on the learning of classroom. In addition to that, we will also provide you some self-assessment test, or we can say practice MCQs that you can, it will be uploaded on your portal. Okay, so you can log in into portal and solve those MCQs. So, in this manner, we will try to cover around quality 300 to 400 MCQs for your each section before your prelims examination. Okay, in the end we will have mock test, AIPMTs are there every month, and in the end we will have Panchasutra test also. Okay, so as this is a first let's say lecture, let me tell you how it will progress. So, we have selected certain number of topics. It's a kind of going to be revision for all of you. I hope that you have also done the self study. Is it going to be the first time learning of geography? Anyone? Yes, I believe that somehow you may have done the self study or may have done the other coachings also, but it is going to be a kind of higher learning. Okay, and I want you to participate in this discussion, ask questions in the classroom so that your doubts will be solved in the classroom itself. Okay. Second thing is that we have selected certain topics where I will give more emphasis. Like first session, you can see that some interesting names also we have given to topics. In the womb of Mother Earth, first chapter, first topic. So, whatever related to the processes going on inside the earth, be it related to volcanism or earthquake, or we can say endogenetic forces or tectonic theories. So, all things we will learn today, we will revise it and solve those MCQs. Like tomorrow's session will be focused on climatology, बहती हवा सा था वो, उसको नाम ऐसे दिया गया है. The reason is we will focus more on climate related phenomenon, and largely they will be wind related, we can say that phenomenon processes. And you can see the PYQs also, that UPSC also focuses on climatology and the applied questions related to climatic phenomenon. ठीक है. Now, two things that you have to follow on daily basis for geography at least, that you should come up with let's say atlas on daily basis. ठीक है. This is very important for prelims, because in between any time I will tell you this place, that place, and you have to immediately see on the atlas. ठीक है, first thing. Second is that you have to daily revise PYQs by yourself also. Okay, so today if you are learning about geomorphology, so go through all PYQs of geomorphology, or you can revise let's say PYQs of climatology today only, because tomorrow you will ask those doubts in the classroom. Do this practice by yourself, because in 2 hours it is very difficult to cover all PYQs also. Although in that practice sheet that you have received, some of the PYQs we have added, we will solve them today. Okay, so try to follow this on daily basis. One more important thing, when I say that this is important, this has been asked, this will be asked, let me tell you, it is very important. Last year PT100 program, have you attended, any one of you? I can see you had attended last year PT100 program. Similar practice we had done. From one session directly 3 questions as it is they have appeared in prelims examination. Climatology as it is I am telling you. Okay, practice questions also. So this is very important, that's why I am telling you that I know what kind of questions will be asked from geography. Okay, I have done the analysis. Second thing, we have dedicated 3 sessions for mapping only, 2 sessions for static part, 1 session for places in news, current affairs, current development. Okay, we will have comprehensive coverage for mapping also, and daily bring the atlas with you, this is very important. Okay, so all these notes will be uploaded on your portal. Okay, already it may have uploaded, okay, so you can download it, you can revise from that. Now few things I will add here while teaching also, that you have to note it down in the classroom. Okay, so let's start with the first session. Right. First of all, as some of you have not seen the orientation session, let me highlight the focus area of UPSC examination. ठीक है, नहीं अटेंड किया है ना? किया है, कुछ लोगों ने ऑनलाइन किया होगा. Right. So which focus areas I had told you that UPSC is focusing in recent 4-5 years especially. पहला क्या था? Concepts from physical geography chapters, especially climatology, oceanography and geomorphology. Now let me tell you, they will not ask direct question in geography. They will not ask direct question. They will ask indirect question. Indirect means application of concept. How they ask application of concept? By asking assertion reason type of question. Statement 1, statement 2. Whether statement 2 is correct explanation of statement 1. This is how they are asking question, right? So we have to be also aware about what type of question is expected. Now in geography largely it is the different phenomenon and processes, and there are causing factors behind those processes. Causing factors, causing forces, right? Like ocean currents, there are causing factors or causing forces, primary forces, secondary forces. For every kind of phenomenon, somehow there is explanation and there will be some kind of causing aspect. So we have to understand that causing mechanism behind any climatic phenomenon or oceanic phenomenon, and then we will be able to solve those MCQs if we understand that mechanism, because they are asking cause and effect relationship, no? Why isotherm bend to the north over the ocean in northern hemisphere in January month? Statement 1. Statement 2, they are talking about ocean current, and they had mentioned that cold ocean current. I don't want blank faces when I read out 2024 prelims question. ठीक है, मुझे इतना तो चाहिए कि आपको वो 100 क्वेश्चन मग अप किए हुए चाहिए. You should mug up those 100 questions. Last year जो मैं पूछा था, right? This was the question, and you can immediately identify that North Atlantic drift current is basically the warm ocean current. They had mentioned that as a cold ocean current. One can eliminate that and easily attempt such kind of question. ठीक है? So that's what I am telling you. Applied questions will be based on understanding. Okay, understanding of concept. Oceanography, climatology, geomorphology. Second, mapping section, and in mapping section 2 aspects are there. One is static portion, other is current development, places in news. Now static portion also has sufficient weightage. Every year UPSC will ask one question from rivers or lakes or hills, mountains, match the following. Waterfalls, Hundru waterfalls, Hoganakkal waterfall, Match the following type of question. Or mountains, Vosges mountains, Block mountain, Fold mountain, Alps, this was the question. Or the rivers, tributaries of Ganga from west to east. So it is basically the atlas reading part, mapping part, and it is static portion. It is static portion. So you have to do atlas reading on daily basis for that. Now, current affairs, places in news, and I had mentioned that what things they are focusing in current development mapping section, largely for world mapping, and that too they are focusing on regions which are in conflict, or there are some kind of civil war going on, terrorist activity going on, there are refugees in that country because of civil war. Like for example, last year they had asked Sudan, right, and they mentioned that there is conflict between armed forces and paramilitary forces. Then they asked about Argentina. So that means socio-economic and political crisis, if it is happening at very larger level. In Argentina there was very high inflation levels. It was more than 100% inflation levels in Argentina. So it was severe economic crisis, okay, last year, and that's why it was very much in news. Okay, if suppose there is any kind of let's say region in conflict, like Nagorno-Karabakh region, conflict between Azerbaijan and Armenia, okay, so such kind of regions they will ask. Or if suppose any country is in news because of such kind of conflict, Ukraine-Russia conflict is going on since last 2-3 years. So it was expected that students should know the boundary countries, border countries of Ukraine. That was asked. In 2021, Afghanistan was in news because of Taliban rule. Taliban took control over Afghanistan. Immediately UPSC asked bordering nation of Afghanistan. That year only. So we have to understand what UPSC asks. And I am telling you, it will not ask any random development or minor development happening in some corner of the world. Rather, it is very prominent development unfolding for long period of time. Okay, ऐसा नहीं कि छोटा कोई पूछ लेगा छोटा सा चीज, बहुत दिनों से वो न्यूज में है. Sudan was continuously in news because of the problem. Okay, if there is question in, let's say tomorrow in prelims related to Israel and conflict, Israel-Hamas conflict, so you should be knowing about the places in that Israel and West Asia region. Syria, again it is in news. In past UPSC has asked Golan Heights, it has asked about Levant region, वही region है ना वो, Golan Heights वहीं पे है. So it gives hints, हमें ये hints है, getting this. Now the common thing that they keeps on repeating, there are 4 important seas, उनके वो borders पूछते हैं. North Sea, Baltic Sea, Mediterranean Sea, Black Sea, Caspian Sea, 5 seas. Every alternate year they will repeat these things. I am telling you, they will repeat these things. Okay, last year there was question on North Sea. उससे पहले जो था वो क्वेश्चन था आपका मेडिटेरेनियन से या ब्लैक सी से, और they will ask about rivers flowing into these oceans. These seas and oceans are always in news also because of some reasons, and that's why we should prepare it very thoroughly. Current developments. Now some developments they will ask from India also. Okay, what kind of current developments they are now focusing for India? It is largely related to infrastructure related projects. Infrastructure, last year it was ports. This year they asked greenfield airports. This was the question. Last year matched the following: Kamarajar port or Mundra port, all these things they asked. So somehow they are in news for different kinds of reasons, but they asked the static portion, or we can say that match the following type. Okay, so we have to prepare this for world as well as India. This is also for world as well as India. Static portion. And I had mentioned that there is one YouTube video 2 years back. I had taken that session what things should be prepared for mapping section in geography. 40 minutes video. I have analyzed last 25 years question papers of UPSC Prelims examination, and I have found out what things they asked in mapping section. Rivers, hills, mountains, mountain passes, or let's say your lakes, wetlands, जो उन्होंने पूछा है वर्ल्ड और इंडिया से, वो सब चीज़ मैंने उसमें मेंशन किया है. वो लिस्ट बनानी है एक पेज, और मैपिंग करते वक्त तो आपके साइड में होना चाहिए. एटलस रीडिंग करते वक्त आपके वो साइड में होना चाहिए, राइट. सो दिस शुड बी द प्रैक्टिस. थर्ड इज दे आर फोकसिंग some questions, okay, some matlab 2 to 3 questions at maximum. They are largely related to economic geography. Like for example, they are asking about resources, distribution of resources, or they will ask about the crops. So that is related to economic geography. Primary activity, secondary activity, tertiary activity. Like last year they asked about cobalt reserves, Democratic Republic of Congo. Or they asked about the ores, ilmenite and rutile, the titanium ores they asked. Or this year, what was the question? Cocoa producing countries, right? Cocoa producing countries, largest cocoa producing countries they asked. So it is related to economic geography, okay. Now you have to prepare basic NCERT for that. You should not refer to any kind of different material. Otherwise what happens is our preparation gets scattered. Somehow we are also preparing that for mains examination. आपने शायद मेंस के लिए नोट्स बनाए होंगे, रिसोर्सेस के लिए, इंडस्ट्रीज के लिए, एग्रीकल्चर के लिए. रिवाइज दोज नोट्स ओनली, ओके. एंड 12th स्टैंडर्ड NCERTs आर ऑल्सो सफिशिएंट, वर्ल्ड एज वेल एज इंडिया, ह्यूमन एंड इकोनॉमिक ज्योग्राफी, okay, and then GC Leong after that, okay. So this is the focus area, and in past UPSC has also focused other, let's say, topics randomly, 1 or 2 questions, like for example vegetation, like which of the above are evergreen type of trees, okay. उसमें उन्होंने पूछा था ना, mango and all these trees were asked. Last year there was this question. Or oil palm related statements, it was evergreens, it is evergreen species or something like that, or native to that particular country. Vegetation, soils, crops, okay. And somehow overlapping aspect with let's say environment also, eco-friendly farming practices. Although it is part of both geography as well as environment, but it is largely learned in environment nowadays, eco-friendly farming practices, okay. So these are the areas that UPSC is focusing in recent times. So prepare them thoroughly, and we expect that UPSC will not change this pattern, because in past also UPSC has always kept focus on these areas only. ठीक है. So in physical geography, conceptual clarity, and in human and economic geography, largely it is, we can say, these are the areas. Okay, fine. Now let's talk about today's session, right. So in this session we will learn about evolution, structure, composition of interior of the earth. All these things you have read, it is also part of 11th standard NCERT. Geomagnetism, it is not there in NCERT, so we will learn few concepts related to geomagnetism, as UPSC is also focusing on this. ठीक है. Yes, online students, yes, good afternoon everyone. If you have any question you can ask in the comment box. ठीक है. Yes. Now geomagnetism, why we are saying in 2022 prelims examination there was question solar storms, okay, or geomagnetic storm and its effect. 7 points were given. Through elimination method one can easily attempt that. But in 2024 mains examination, what they asked? Aurora formation. This year's mains examination, I always tell student that take cue from your prelims for mains and for prelims, for mains from prelims. ठीक है, जो फोकस वो कर रहे हैं, अरे फ्रेमिंग तो वही लोग कर रहे हैं ना, सेम लोग ही, तो उनके माइंडसेट में जाइए आप. ठीक है, वो कहाँ पे सोच रहे हैं, क्या चीज़ पे फोकस कर रहे हैं, राइट. सो दैट एरिया शुड बी फोकस्ड बाय अस ऑल्सो. right? So this is the new area they are exploring now, geomagnetism. So we will learn few concepts, then endogenic, exogenic movements and tectonic theories, three prominent tectonic theories that we have, right? So first of all, the theories of formation of earth, you already know about this. There are some classical theories and there are some modern theories, right? So classical theories largely include the planetesimal theory, hypothesis we can say, first given by Immanuel Kant and thereafter improved by Laplace. UPSC will not ask about these theories. In past also they have not asked about it. Why? Because these theories have been actually criticized, okay, by the modern theories, and most accepted theory that we have today is Big Bang theory. Okay, most accepted theory is Big Bang theory. So UPSC will not ask the debated theories, they will ask the accepted theory even if they are asking. Okay, so planetesimal hypothesis of Kant and Laplace suggests that initially the universe formed from the clouded nebula, okay, clouded nebula that was made up of dust and gas. Okay, initially it was slowly rotating, but over the period of time, due to unequal distribution of masses, they started moving in a faster direction. And because of accretion, accretion means what? Larger masses attracting the smaller masses. That resulted into formation of larger bodies at the center of that nebula. Generally, the present day center is basically called as stars, while the remaining bodies which started revolving around it are basically okay. So according to Kant and Laplace, what they said is basically there was a fast moving nebula which resulted into formation of rings around it, and then that started cooling down, forming the 9 planets. Okay, 9 rings were formed and 9 planets were formed from those 9 rings. ठीक है, ऐसा एक बेसिक कॉन्सेप्ट है. Thereafter second concept talks about planetesimal hypothesis. See, this is basically the nebular hypothesis. ठीक है, nebular hypothesis, it says like this: clouded nebula, thereafter at the center there was larger energy. Now the rings are formed around it, and thereafter from those rings the present day planets are formed. Now second theory is about Chamberlain and Moulton, and it is binary theory, binary star theory we can say. So according to this theory, how the present solar system is formed is because of one star actually moved from near the sun. Okay, in the geological past, one star which was very huge in size moved from near the sun, and that resulted into force of attraction on the surface of sun and extracting some mass material from the sun's surface in that direction of movement of star in a cigar shaped, and in that shape basically the whatever the matter that was extracted from the sun's surface started revolving around the sun, and this particular star moved ahead. Okay, this star moved ahead while this mass started revolving around the sun, and later through accretion process these planets are formed. Okay, so basically these are hypotheses, no, that's why they are saying hypothesis, and they have been criticized. Okay, so they are not largely accepted for the formation of universe. Now the Big Bang theory, we are aware about that. Now around 14 billion years ago, what had happened is there was one tiny singular atom having unimaginably small volume and very high density, and that exploded in a very violent manner. And because of that what happened is there was expansion started from that region. So that means the energy that released from that violent explosion started getting converted into mass. Einstein's equation, E is equal to mc square. We learned in school, but we will never understand what is E is equal to mc square. ठीक है, बट आपको इतना तो पता है ना कि एनर्जी एंड मास इंटर कन्वर्ज, ठीक है, यूनिवर्स में. सो पहले क्या था, एनर्जी था और वो मास में कन्वर्ट हुआ. And this is how the planets or first atom was formed and thereafter the planets were formed. Now how we have understood that universe was formed and presently it is expanding? It is through observation. So Hubble telescope, through Hubble telescope we have found that the universe is expanding. Okay, that means the distances between these galaxies is increasing. The distances between these galaxies is increasing, but there is small criticism of this theory also. क्या है criticism?
Reason for explosion.
No, that is fine. Reason वो तो हम assume कर रहे हैं कि उस time पे explosion हो गया है. उससे पहले क्या था, it is not able to explain. That is true. Okay, but what we say about the criticism here is it is not let's say able to explain why galaxies themselves are not expanding. ठीक है, उन्होंने एक्सप्लेन करने के लिए बलून का एग्जाम्पल दिया है. ठीक है, इफ वी हैव अनइन्फ्लेटेड बलून विथ अस एंड इफ यू सिंपली मार्क सम पॉइंट्स ऑन बलून एंड देन इन्फ्लेट इट, व्हाट हैपेंस, द ओवरऑल सरफेस इंक्रीजेस as well as those dots, their size also increases. Let's suppose those are the galaxies. That means galaxies themselves should increase in size. But this has not been observed. This has not been observed. Rather, distances between the galaxies is increasing. ठीक है, तो वो उसका एक criticism है. Fine, okay. Now, our solar system, very simple. Let's say information from 6th standard NCERT. This is from 6th standard NCERT. Sometimes UPSC asks so simple question that in examination we feel that how it can be so simple, but we may get confused. Why? Because we have overlooked that thing in NCERT. We feel that ये तो हमें आ जाएगा, तो हमने उसको रिवाइज नहीं किया रहता है, right? So basic information you should be reading from this. And let me also एक्चुअली एक अच्छा एक्सप्लेनेटरी वीडियो है. ज्योग्राफी में थोड़ा आप वीडियो के थ्रू काफ़ी चीज़ें समझते हो, ठीक है, तो वो ज़्यादा इफ़ेक्टिव है. क्या हुआ, इसका आवाज़ क्यों नहीं आ रहा है? Just a moment. ठीक है, कोई बात नहीं, फिर वो आप वो नोट्स में से कभी देख लेना, उसमें मैं बताऊंगा आपको, ठीक है, या वो आता है तो मैं दिखा. कौन सा? ओके,
सर इसका लिंक प्रोवाइड करा दीजिए.
हाँ हाँ, वो लिंक दिया हुआ है नोट्स में, ठीक है, तो नोट्स में लिंक दिया हुआ है, वो उस पर क्लिक करोगे ना तो आप वो वीडियो देख लेना है, ठीक है. सो बेसिकली इट इज़ एक्सप्लेनिंग, यू कैन ऑल्सो सी, एक्चुअली देखने में भी काफ़ी इंटरेस्टिंग है. अब देखिए 2 मिनट में बताना.
No moons, and they are relatively small.
ठीक है.
Our solar system is one of over 500 known solar systems in the entire Milky Way galaxy. The solar system came into being about 4.5 billion years ago when a cloud of interstellar gas and dust collapsed, resulting in a solar nebula, a swirling disk of material that collided to form the solar system. The solar system is located in the Milky Way's Orion star cluster. Only 15% of stars in the galaxy host planetary systems, and one of those stars is our own sun. Revolving around the sun are 8 planets. The planets are divided into 2 categories based on their composition: terrestrial
Terrestrial,
and Jovian.
Jovian planet.
Terrestrial planets, including Mercury, Venus, Earth, and Mars, are primarily made of rocky material. Their surfaces are solid. They don't have ring systems. They have very few or no moons, and they are relatively small. The smallest and closest to the sun is Mercury, which has the shortest orbit in the solar system at about 3 Earth months. Venus is the hottest planet, with temperatures of up to 867 degrees Fahrenheit due to an atmosphere of carbon dioxide and extensive lava flows.
Suppose there is question in prelims
To
like
this
this.
world of fire.
Like why Venus is the hottest in our planet? Why it is not Mercury? It is because of 2 reasons. One is the atmosphere or the clouds. Largely it is made up of CO2 and SO2, sulfur dioxide also. Okay, and it is second is volcanic eruptions, extensive volcanic eruptions.
Is a configuration of planets and other celestial objects, all revolving around a life-giving star, make it a
Fine. So this much information is sufficient. So we were learning about so planets. This information you can read. Now formation of moon. Okay. So moon is formed through a event after let's say formation of sun. There was a giant let's say spat event that had happened wherein a large body of mass impacted Earth's surface that resulted into some mass of Earth ejected from its surface. The present day depression that we see in the form of Pacific Ocean is basically due to that impact, and after that it started moving around the sun or revolving around the earth, pardon me, okay, revolving around the earth. Now because of this let's say impact, when that mass started revolving around the earth, that got tidally locked with the earth. What is tidal locking? देखिए मैं ये बार बार अभी बोल रहा हूँ क्योंकि ये एनसीईआरटी और उसके बियॉन्ड का नॉलेज है अभी सब. व्हाट डू यू मीन बाय टाइडल लॉकिंग?
We can see only one face of the moon.
Yes, very good. The reason is?
Both rotate in synchronization.
Yes, tidally locking is the phenomenon wherein the larger body exerts such kind of gravitational field on the smaller body revolving around it, so that the rotation aspect of that smaller body is controlled by the revolution of that body around the larger body, and because of that now the time period of its rotation and time period of its revolution is same. Okay, this is basically tidal locking. This is called as tidal locking, rotation around its own axis and revolution around the earth, same time period, and that's why we see only one face of moon from the earth. Okay, one face of moon from the earth, tidal locking phenomenon. Okay, now evolution of atmosphere, hydrosphere. First of all we will talk about evolution of lithosphere. So how Earth's lithosphere?
So like Earth is tilted like 66 degree.
Hmm.
And we just saw Uranus is also tilted, and I don't know which angle, but is it like all the planets are tilted and somewhat
Yes, they are tilted, but the Uranus is basically rotating in a vertical direction like this. Okay, all the bodies are rotating like this, but Uranus, that means its axis is like this in a horizontal manner. Okay, that means plane of rotation and plane of revolution around the sun, it is making larger angle. Okay, it is up to 90 degree. That is less in other planets. Okay, this is the difference actually. Okay, now you should also understand that some planets rotate from west to east like Earth around its own axis, west to east, right? But some planets rotate from east to west also. Venus and Uranus, ऐसे दो planets है जो उल्टा घूमते हैं. Okay, from east to west. Now that is also unique information, right? Yes. Now evolution of lithosphere. What is lithosphere? Yes, crust and uppermost solid part of mantle. It is called as lithosphere. Its thickness can extend from 10 km to even up to 100 km. Okay, so basically it is called as lithosphere. All the tectonic activity happens within the lithosphere. Every earthquake that we observe on the earth sphere generally originate within the lithosphere. Okay, so tectonic activity, that's why we call it. Now, evolution of lithosphere. What had happened is when the earth was getting formed, the energy inside the earth in the form of heat was getting dissipated towards the space, and that's why it started cooling down. So the first layer to be cooled down was of course the external layer, the outer layer, and that's why the outer layer, that is crust and uppermost mantle part, is now solid in state, while the interiors are still hot because of residual heat that earth carries. Okay, residual heat is basically heat that earth is carrying since the time of formation of earth. Also, the earth's interior is having some of the radioactive material. So there is continuous radioactive decay going on, and that is resulting into energy production, heat production. That is also providing heat inside, especially mantle, that asthenosphere region. Okay, that's why it is liquid, and this is how there is formation of interior of the earth. We will learn in detail about that. Okay, second is atmosphere and hydrosphere. Okay, so how atmosphere is formed? Through three processes. What are these processes? First, the primordial atmosphere was completely different than the present day atmosphere. Its composition was different. Okay, that is, primordial atmosphere was having little free oxygen, but at present we have huge free oxygen in our atmosphere. The primordial atmosphere had hydrogen, helium, and even ammonia, methane, these types of gases. But that atmosphere was removed from strong solar winds. Okay, as these are terrestrial planets, they are located near the sun. Strong solar winds basically removed this particular primordial, ancient type of atmosphere from the earth's surface. Now, after that, there was process called as degassing started. It was simultaneous, of course. Degassing is basically emission of gases from interior of the earth. Okay, so through volcanic eruption or through geysers, basically whenever the interiors of the earth, whatever the gases were formed inside the earth, they found way outside the earth. Now, how they came outside the earth? Because the gases have lower density, right? The gases have lower density, or the gases will try to escape from high pressure region to low pressure region. Now, inside the earth there is high pressure region, okay, and they will try to escape towards the low pressure region. That's why these gases came out whenever there was let's say path, cracks, volcanic eruption or faults. So वहाँ से वो बाहर आ गए. and now the present day composition of atmosphere is influenced by this degassing phenomenon. Okay. Second is now modification of that composition. So how it was modified? It was modified through photosynthesis phenomenon. Okay. So when the life started flourishing in the oceans, so oceans started flooding with oxygen. Okay. And because of that, it was exchange of that oxygen, carbon dioxide from the ocean surface, and that led to more and more oxygen on the in the atmosphere. This is how the life also started flourishing on the land. Okay. Thereafter, we should understand the formation of hydrosphere also. So hydrosphere, so water. So water is basically water vapor, and that water vapor was not available in the primordial atmosphere as such largely. That water vapor was, let us say, made available through degassing phenomenon. Okay. Through degassing, water vapor came out through volcanic eruption, and that resulted into condensation, cloud formation and precipitation, and over the period of time there was formation of hydrological cycle on the earth's surface. All that moisture or water vapor started moving on the earth's surface in the form of water cycle. Okay. So evaporation, condensation, precipitation, surface runoff, subsurface runoff, again there is evaporation. This is how the hydrological cycle started, hydrosphere. Okay. So this is evolution of atmosphere and hydrosphere. Now, the structure and composition of interior of the earth. Right. So structure and composition, first of all the sources, direct sources, indirect sources. 10 years, 15 years back UPSC used to ask such kind of simple direct questions like which of the following is indirect sources of information about, or how many of the above are like direct sources of information. So we know, we read that in NCERT, 11th standard NCERT, direct sources. So study of surface rocks, or study of rocks in the mines, or we can say study of volcanic eruption and the lava that is coming on the surface and the rocks which are formed from that lava. So that is basically direct observation, right? That is direct observation. Or deep ocean drilling projects are there, or gold mines in South Africa, they are around 3 to 4 kilometer deep, right? Deep drilling projects like one in Kola Peninsula. इसलिए मैं बोल रहा था कि मैप एटलस लेके आना है. Kola Peninsula, immediately you can see in Russia, on the northern side of Russia, there is Kola Peninsula along the Arctic. So there is a deep drilling project going on. Okay, so it is around 12 kilometer deep. So from that also we get information. But 12 kilometer deep is not that deep, right? The diameter of the earth, radius of the earth is very large comparatively, and we cannot reach into that depth to understand or study what material lies there, and that is why we rely on indirect sources of information. And the most prominent one is seismic activity. The other being gravitation studies or gravitation anomalies or magnetic anomalies, magnetic field. So we know that gravitation gravitational force near the poles is more as compared to equator. Why?
Because the radius is low.
Yes, radius is less, or the earth is bulged near the equator and flattened near the poles. So from the distance from the center is less near the pole. Small g, value of small g in physics we have learned, right? So it is more near the poles and less near the, because it is inversely proportional to that r square or something like that we have learned. Okay? Then magnetic anomalies. From that also we have understood the distribution of magnetic material inside the earth. In geological past, the magnetic poles of the earth have changed their positions, and accordingly whatever the new rocks were formed or material was getting formed, that got aligned to the existing magnetic field of that time. It could be normal polarity, it could be reverse polarity. We will learn that in geomagnetism. Okay. But this has helped us to understand that the distribution of magnetic material, where it is concentrated, in which layer it is concentrated. But the most prominent one is seismic activity. Even meteors, their study. Why? Because the universe or the solar system, everything is formed from a single origin. We believe that, and that's why studying meteors or the rocks will help us to understand what our Earth's interior is made up of. So, seismic activity. Okay, so we'll learn in detail about seismic activity because that is the most reliable source of information about the structure and composition of interior of the Earth. Last to last year, there was very simple question on P waves and S waves. 2023 prelims. In past also UPSC has asked question on primary waves, secondary waves, okay, focus of the earthquake, simple questions they have asked. So, we will learn some concepts here, very important. Okay, seismicity. So, first of all, let us try to understand what is earthquake and then we will learn about the earthquake waves. What is earthquake in simple terms? रैंचो की भाषा में बताइए. Shaking of earth surface, it is simply the earthquake. Now, that shaking largely happens along the fault region. Fault region is basically the area or the plane wherein large rocks are having interface. Either they are moving towards each other or they are trying to move away from each other. Let us say these are the two rocks or this is the interface. Now, you may not be seeing, but I am forcing these hands away from each other, one in this direction and other in this direction, but still it is not moving. Why? Friction. Very simple. There is a friction between these two rocks that is holding these rocks in this position. But if suppose due to external forces that friction is overcome, then these rocks will slide down like this, or it can be in this direction also. Okay, they can slide along this fault plane and that will result into the built up energy. It will release that energy along this fault plane at certain point along that fault plane, that is called as focus of earth or hypocenter. Okay, focus of earthquake I am saying. It is called as focus of earthquake. Okay, and that will release the let us imagine that there are two rocks and this is the fault plane. So, let us say at this point there is release of energy, this will be called as focus or it is called as hypocenter. Okay. Now, this will be first the earthquake waves will move in all direction and the first one to reach on the surface, it will be exactly above the focus, it is called as epicenter of earthquake. It is called as epicenter of the earthquake. Okay, these terminologies are important, basic terminologies. Now, the energy that is released from the focus moves in all direction in the form of earthquake waves. It moves in the form of earthquake waves and these waves have different characteristics. There are different types of earthquake waves based on their characteristics. Some of them are behaving like sound waves or longitudinal kind of waves. Some of them behave like transverse or like light waves, okay? Light radiations or electromagnetic radiations. So, based on those properties we have categorized them and also based on when they arrive on the earth's surface. Now, these earthquake waves are detected on particular instrument that is called as seismograph. Okay, how we are measuring the earthquake? We are measuring on that seismograph. Okay, and measurement of earthquake happens on two scales. This has been also asked in past. First, Richter scale. Zero to 10 and Mercalli scale. Richter scale calculates the magnitude of the earthquake, okay, magnitude, and it is logarithmic scale. It is logarithmic. Now, what do you mean by logarithmic? What is the significance of logarithmic scale?
Scale it is calculated with the base of 10. So if the scale is 10 power 6, the answer will be 6.
So basically in layman language we can say that it will be a kind of exponential graph, logarithmic scale. So that means if the magnitude of earthquake is like 1 or 2 or 3, it is not of larger scale. But if it is slightly increasing beyond 5 or 5 to 6, 6 to 7, it is going to be huge magnitude. Okay, so ये उसमें difference है logarithmic में, and that's why the major destruction that is caused by earthquake is of larger magnitude after 6. Okay, generally ये इस range में होता है. Okay, because of this logarithm, have you understood this? Generally 3 to 4 वाले tremors होते हैं, tremors दिल्ली में भी आते हैं. ठीक है, अगर उधर नेपाल इधर अर्थक्वेक हो गया जम्मू कश्मीर में, उधर अफगानिस्तान में, दिल्ली में भी ट्रेमर्स आते हैं, राइट, बट दे आर नॉट ऑफ दैट मच वी कैन से मैग्नीट्यूड और इवन वी विल से इंटेंसिटी. नाउ व्हाट इज इंटेंसिटी स्केल? इट इज कॉल्ड मर्केली स्केल. Intensity scale is related to the level of destruction that earthquake is causing. Okay. Now you tell me, if there is an earthquake of 8.1 Richter scale happening in Antarctic and 8.1 Richter scale earthquake happening in Delhi, ऐसा नहीं होगा, let's imagine, but you can understand the level of destruction it can cause. वहाँ पे कौन है? वहाँ पे कोई नहीं है. No one is living there in Antarctic, right? There is no infrastructure, human built infrastructure. So level of destruction, this is the difference. And here the Mercalli scale will mark very low in that Antarctic earthquake. But in Delhi it will be very high, despite of same Richter scale magnitude. Understood? So this is intensity scale and it is, we can say, Richter scale. Basic, हाँ.
So what is Mercator's projection?
Which one?
Mercator's projection.
Is it related to this scale?
I read the terms, I cannot recall it.
Okay, I will note it down. ठीक है. What do you spell it?
Mercator's projection.
It is related to earthquake?
Yes,
Okay, let me see it. I will tell you tomorrow. ठीक है. Mercator's projection. Okay, fine. ठीक है. If it is related to this one, I will explain it. If it is in very detail about let's say earthquake and its detailed study or related to geological concepts, ठीक है, तो it's not of that importance. Fine. Now after this, sorry, Mercator's projection he is saying. Okay, don't Google it now. Just ठीक है, हम बाद में देखेंगे उसको. Like it's वही information हमें चाहिए रहती है, right? Fine, it's okay. Now let's talk about the earthquake waves. Okay, from focus in all direction, all these waves are released, and first one to arrive and detect on seismograph, they are P waves. They are P waves. Arrival times. First to arrive, P waves, and that's why they are called as primary waves. First one to arrive. Second, S waves or secondary waves, and after that there will be surface waves detected on the. So first of all we should understand there are two types of earthquake waves, one body waves and second surface waves. Body waves means those waves passing through body of earth, interior of the earth. Simply we will call them as body waves. P waves and S waves are body waves, and surface waves are those waves which are formed due to interaction of P waves and S waves with surface rocks. They are called as surface waves. Okay, and these surface waves are more destructive. They are more destructive. We will see the types also. ठीक है, उसके types क्या है? Rayleigh waves and love waves. Okay, but first of all, let's talk about P waves and S waves and their properties, distinction between them. This was asked in prelims examination 2023. Properties. Okay, so we know that P waves are first one to arrive, that's why they are called as primary waves. Now the property, the distinguishing property of P waves is they behave like longitudinal waves. Okay, they are longitudinal waves or similar to sound waves. When we say longitudinal waves or sound waves, of course they can pass through all three mediums. Okay, so gaseous, liquid and solid medium. So from that we understand primary waves or P waves can pass through gaseous, liquid and. Now second, the sound waves or longitudinal waves are basically vibratory waves. So they will form the compression and rarefaction like this when they move inside the medium. Compression and rarefaction. Spring की movement देखी थी आपने, spring physics में पढ़ा था आपने, ठीक है, oscillations. So basically longitudinal waves are those waves forming, and because of that what they are doing to the material through which they are passing, they are squeezing and enlarging, squeezing and expanding the material. Okay. Next thing, these waves are basically moving or vibrating in the direction of movement of that wave. That means if this is the direction of movement of wave, these waves are vibrating like this in the direction of movement of wave. Okay, in the direction of movement of wave. These are the P waves. Now S waves, second to arrive, that's why secondary, and as they are arriving secondary, that's why their speed is less comparatively than primary waves. Okay, their speed is less comparatively. Now it has been observed that S waves behave like transverse waves, and transverse waves do not pass through fluids. They do not pass through fluids, they can pass through only solids. Okay, fluids matlab kya hai? Gaseous and liquids. Together they are called as fluids, right? So they cannot pass through fluids, they can pass through. Now this property that we have understood has helped us to understand what Earth is made up of. Okay? So remember this. Now as these are transverse waves, they will form the crest and trough, sinusoidal waves, right? So when they are forming crest and trough, what happens to the material through which they are passing? Distortion. It is distorting the material through which they are passing. Distorting मतलब क्या है? ऐसे करना, ऊपर नीचे, ठीक है? The way sea waves move, so it is distortion. Okay. P waves were doing squeezing and expansion, squeezing and expansion. This is called as distortion. This was asked in that statement. Okay, distortion. Now next is vibration. So as it is sinusoidal wave, the material which is vibrating is basically perpendicular to the direction of wave. If suppose this is the direction of wave, the material is vibrating like this, right? Simply in waves, sea waves, what happens? The water molecules are moving like this and the wave trains pass through it. It is simply the energy that is moving, not the water molecules. In the same manner, here also S waves, when they pass, there is perpendicular vibrations to the direction of that wave. These properties we have to remember here. Now the next concept is shadow zones, and from that we have understood that S waves do not pass through core. Let's understand this concept. Okay, shadow zones. So P waves, let's say this is the origin of the earthquake and P waves are moving all along the direction. Now first of all you can see that these waves are getting refracted towards the surface as they move inside the earth. They are getting refracted, they are having curved path, they are getting refracted and they are having curved path, these two properties. Second, when they are passing through core, you can see further refraction and then coming out of core. But when they are passing through core, it has been observed that through multiple refraction, there is formation of one zone where P waves are not detected on this surface. This surface we are talking, Earth surface, and on this side also. So from this location to up to 105 P waves are detected. From this location on other side 105 degree the P waves are detected, but from P 105 to 145, 105 to 145 P waves are not detected. But beyond that they are further detected. That means they pass through core. That means they pass through core. ठीक है, ये चीज समझिए. Now S waves they are found up to only 103 or 105. Beyond that S waves are not detected. So this is the larger area. Rather it is considered that 40% of Earth's surface is, let's say, shadow zone of S waves. 40% of Earth's surface is the shadow zone of Earth's surface. Let's say S waves, sorry. Now, as they are not found beyond this region, it has been observed that they do not pass through core. They do not pass through core or that outer core. नहीं, core जो है, it is made up of two parts, inner core and outer core. And outer core is made up of liquid. From this property only we have understood. We have not gone there and seen whether it is liquid or gaseous, right? We have understood that from this property, study of seismic waves. Now, from this we have understood that the outer boundary of core or this medium somewhere is made up of fluid, that is either gas or liquid. Either gas or liquid, right? Now, we are saying that it is made up of liquid. Why not gas?
Speed was calculated.
Why we are saying?
Gas was released during the formation of the Earth.
Excessive compression due to the pressure of Earth wall and layers.
Yes, so what will happen then?
It will exert pressure on that.
Yes, and what will happen to gas then?
The molecules will be.
Yes, simply if it is in gaseous form, it will not stay under that much high pressure in that area. It will always escape to low pressure area. It is highly fluid, right? Gas is highly fluid. But if it is in liquid form, it can stay under very high pressure. It can stay under very high pressure, and that's why it is said that it is in liquid form, not in gaseous form. And the inner core is made up of solid. Now, why we are saying that inner core is made up of solid?
High pressure.
Huh? Because of presence of heavy metals, knife layer, and at that kind of high pressure, these heavy metals cannot, let's say, even be liquid. ठीक है, वहां पर इतना ज़्यादा liquid नहीं होंगे वो, ठीक है, उनका melting point बहुत high होता है, ठीक है, वो जो heavy metals है उनका melting point is very high, and because of that they are still in solid state there, and high pressure on them increases their melting point further. High pressure increases their melting point, and that's why this part remains solid. Okay, but this remains liquid. Also, you should understand that there is a kind of significant change in temperatures at this boundary and this boundary, and that's why there is continuous movement of this liquid material like this. I will explain this in geomagnetism. Okay, there are continuous movement of that liquid layer like asthenosphere. asthenosphere में जैसे मूव हो रहा है मैग्मा, तो वैसे वहां पर ये लिक्विड लेयर्स मूव कर रहे हैं. Because of that, magnetic field is formed. Fine. Now we have understood 2-3 properties from this shadow zone. One, what is this? Curve path. Curve path suggests that
Refraction wave.
when waves are curved, or basically when they are not passing in a straight line, that means there is change in the medium or density of medium. Okay? So that means it is made up of, we can say that heterogeneous medium. The Earth's interior is made up of heterogeneous medium. Okay, the same rocks are not found throughout the Earth. First thing. Second, it is refracted in the outward direction. It's not getting refracted like this. That shows or that suggests density is decreasing towards the surface. है ना? Decreasing towards the surface as waves are refracted away from the axis. High density to low density medium. ठीक है, कुछ स्टूडेंट्स ग्रास्प इजीली कर पाते हैं क्योंकि उनका फिजिक्स अच्छा था शायद स्कूल में या जो भी है. देखिए जब हम पढ़ते थे वेव्स के बारे में, ऑप्टिक्स में पढ़ा था, ऑप्टिक्स में, ठीक है, तो वहां पर हमने देखा था when the light was passing from air to that glass medium, it was basically from low density material to high density. So refraction was towards the axis. But when we said that light is coming out of that glass, so it is high density to low density material. So refraction was away from the axis. So it is basically away from the axis. That's why we are saying. And from this we have understood that density of material goes on increasing from surface to the interior of the earth. Composition. Third property, this one, S waves do not pass through mantle core boundary or outer core, and that's why we are saying that it is in liquid state. It is in liquid state. Now, one more important property that you may not have heard or read, it is about velocity. It is about velocity. It has been found that at certain locations within the earth, there is sudden change in the velocity of these waves. There is sudden change in velocity. What does it show? It shows there are discontinuities inside the earth, the layered structure, right? So, crust, mantle, outer core, inner core, there are discontinuities, there are transition zones, and there is significant change in the material beyond that zone. We have understood that from change in the velocity of this. ये हमने नहीं पढ़ा रहता है, ठीक है? So it can be also asked. Now, from this, you should know certain properties of interior of the earth. So earth is made up of prominently 3 layers: crust, mantle, core. Within that also we can divide crust into upper crust, lower crust. The discontinuity which separates upper crust and lower crust, Conrad discontinuity. Conrad, C-O-N-R-A-D. ठीक है? Now, you can see here lithosphere, crust and uppermost solid mantle. Let's say this is the mantle. यहाँ पर दिखा है देखो. This is the mantle, right? Uppermost solid mantle is this one. Right? Uppermost solid mantle. And उसके ऊपर जो है crust. Together it is called as lithosphere. Now when we learn plate tectonic theory, we will call it as lithospheric plates. The outermost solid crystalline part of the earth's surface. Lithospheric plates. That means it is divided into plates. Okay. Let's say there is a container of water and there are different wooden blocks floating on the water. Simply the earth's crust is like that. It is floating on the liquid asthenosphere. यहाँ पे देखिए. This is the asthenosphere, the liquid part of upper mantle. Liquid part of upper mantle, and this is considered as source of magma. Now here the temperatures are excessively high because of 2 reasons, sources of heat. One is radioactive decay of the radioactive elements, and second is residual heat. Okay, so the magmatic currents are flowing in the asthenosphere. We will learn in detail about that tectonic theory, convection current theory, and let's say sea floor spreading hypothesis. Now, beyond that, what we observe, there is mantle, upper mantle, lower mantle boundary. Now, simultaneously, we should also learn about composition and other properties. If we talk about the upper crust and lower crust, we will call it as continental crust and oceanic crust. Okay, oceanic crust. Now, continental crust is made up of largely silica and magnesium composition, and the average density is 2.7 gram per cc, continental crust, and average thickness is 30 kilometer. It can extend up to 70 kilometer underneath large mountain ranges like Himalayas. Okay. Then oceanic crust. Oceanic crust is largely made up of silica and magnesium, Saima. Okay, Sial, Saima. Yes, silica and magnesium. Now, the average density is 3 gram per cc and average thickness is 5 kilometer. Less thick, it is thinner, oceanic crust. Also, it is very younger as compared to oceanic crust, continental crust, younger. Nowhere around the earth it is more than 200 million years old. Okay, so it is younger than continental crust. ये भी हमें समझना है. Okay, there can be question in prelims. All right. So thereafter, what is this discontinuity, upper mantle and lower mantle? No, it is repeti. The crust and mantle, it is moho, and upper mantle and lower mantle it is repeti. Okay, this lower mantle and this part is solid in state. Now further, mantle core boundary. Okay, the mantle core boundary is Gutenberg. Okay, Gutenberg boundary, mantle core boundary. Outer core is in liquid form, you can see, and this is in solid form, inner core. This boundary is Lehmann boundary or discontinuity. They are discontinuities, okay, inside the earth. Now, regarding the volume and mass, बताइए क्या सीक्वेंस है? If we talk about the volume, crust, it's only 1%. Mantle, it is about 84%, and core is 15%. Okay, and regarding mass, again crust is around 1%, mantle 64%, and core is about, what is that, 35%. So mantle is larger as well as heavier, okay, as compared to, and crust is very small comparatively. ठीक है, it is very small. So ये information NCERT में नहीं है, GC Leong में नहीं है, right? And UPSC may not ask factual thing. UPSC will ask statement, right? Volume of mantle is more than volume of core. Okay, such kind of statements they will ask. क्योंकि आप facts तो mug up करके जाता है ना, statements को फिर सोचना पड़ता है, right? Yes. Now, after this, structure and let's say composition of the earth, ठीक है, ये discontinuities लिखे हुए हैं यहाँ पर. Geomagnetism. Quickly we'll revise this. Geomagnetism, important concept. One is dynamo theory of formation of Earth's magnetic field. So many students do not understand this concept. Let's try to understand first dynamo theory. What does it mean? So Earth's magnetic field, or the magnetic field of any planet, there are some necessary conditions. First, there should be adequate rotatory speed of that planet around its axis. Second, its interior should be made up of fluids. Okay, ये पता होना चाहिए. Third, it should be having sufficient content of iron or such kind of, let's say, metallic content which can carry charge. Right? These are the preconditions. So magnetic field of the planet will be formed when these preconditions are, we can say, satisfied. Okay. Now Earth satisfies these conditions. How? Earth's axis, it is tilted, and yes, of course, it is rotating around its axis with sufficient speed. Second, the Earth's outer core is in liquid form and it is made up of iron. Okay, knife layer we call it, right? Interiors. So we can say that, you can first of all see here the diagram. It is the outer core and inner core. Okay, this is the outer core and this is inner core. Okay. Now outer core is in liquid form and the iron particles in that liquid form are basically moving from this boundary to this boundary because of thermal differences. Because of thermal differences. Here there is more temperature compared to this. Okay. So because of that, thermal convection currents are formed there within this outer core. Now when these iron particles are moving in that thermal convection current in the outer core, what happens is they start carrying the charge. Okay, they start carrying the charge with them. Now we have learned this in physics, that whenever the charge is moving, it leads to formation of current. Whenever the charge is moving charge is basically current, or current is moving charge, right, in a conductor. Now when that charge is moving or current is moving in the form of solenoid, it is going to create a magnetic field around it, or simply a charge inside the conductor, flowing inside the conductor produces magnetic field around it. It forms the magnetic field around it. When I say this is the conductor and when the current is passing through it, it creates magnetic field around it. It is magnetic effect of electric current, we have learned, right. Now here also the charge is passing continuously, that is why it acts as a conductor, but it is moving in a coil like this. It is moving in a coil like this, and that is why we call it as a solenoid. Solenoid bhi padha hai humne physics mein, right. So when it is moving in a solenoid, there is formation of magnetic field lines which are moving inside the solenoid like this. Inside, outside like this. Okay. Now all these iron particles, when they are independently forming this magnetic field, how does it is forming a larger magnetic field of the earth, and that too in single direction? It should be in random and it should actually neutralize each other. Ideally it should neutralize each other, but it is aligned in a one single direction because of one effect, that is called as, that is why we said rotation of earth around its axis. Okay. Because of Coriolis force, all the magnetic field is aligned in one single direction. Okay. And now we are having larger magnetic field of the earth form, and the earth is acting as now a large bar magnet. It is acting as a large bar magnet. Okay. So first of all, the charge that is formed, it is forming a kind of current. Current is resulting into magnetic field, and that magnetic field is aligned in a single direction. Now you must be thinking, sir, अगर ये millions of years तैयार हुआ है, millions of years ago when it was formed, it must have been actually dissipated till the now. ठीक है, तो how it is sustaining till today? It is because of self-sustaining character. Okay, self-sustaining. Have you seen dynamo? सुना तो होगा आपने, साइकिल पे लगाया हुआ रहता है, गाड़ी में भी होता है, साइकिल पे हम पेडल करते हैं तो सामने लाइट चलता है, बल्ब जलता है, दैट इज डायनामो. सो दैट मीन्स till the time earth will rotate around its axis and till the time the outer core is churning, there will be formation of magnetic field. If the rotation stops, then it will stop. It is self sustaining. Okay, it is self sustaining. ये हमें समझना है इसमें. Why? अब समझो, आपको रीजन पूछा है. रीजन इज बिकॉज ऑफ रोटेशन ऑफ अर्थ. If rotation, let's say there is a question tomorrow that if earth stops rotating around its axis, which of the following effects will be seen? ऐसा क्वेश्चन आ सकता है ना. Whatever things that are related to Coriolis effect, they are going to stop because they are because of rotation of earth. The day and night phenomenon that we are witnessing, it is because of tilted axis, rotation of earth. It will stop. तो एक साइड में है तो एक ही साइड में रहेंगे, है ना हम. अंधेरा है तो अंधेरा कायम रहे, दूसरा है तो हमेशा ऑल टाइम सोलर एनर्जी, तो यही चलता रहेगा. तो देयर कैन बी सच अप्लाइड क्वेश्चंस. सो यू हैव टू थिंक rotation of earth, okay, Coriolis effect is because of rotation of earth. If tomorrow it stops, then Coriolis effect stops. Fine? Okay. So this is dynamo theory. Now we have let's say formation of earth's magnetic field. Pay attention here. There is a kind of bar magnet put in the center of the earth. It behaves like this, earth's magnetic field, and there are formations of north magnetic pole and south magnetic pole because of it. Now for our understanding, what we have done is we have named this particular pole as north magnetic and this as south magnetic pole. But inside the earth, this bar magnet is like this, south pole, north pole. Inside the earth, it is south pole and north pole. Imagine that this is magnetic needle. How it is aligning when it is freely suspended like this? It will align like this. North pole of this will be attracted towards north pole of earth, right? Ideally opposite poles should attract each other. तो ये तो आपने सोचा होगा ना कि ideally inside the earth it is south pole. But for our reference, we have named it as north pole for layman language, or we can say understanding of common people. Why? Because if suppose the captain of ship is having the compass, and in that it is moving like this, the compass is showing like this in the north direction, and if suppose there is mention on the compass that it is साउथ डायरेक्शन, तो ही विल बी कंफ्यूज. मुझे तो नॉर्थ में जाना था, ये साउथ दिखा रहा है. उसको क्या फर्क पड़ता है? उसको तो सिर्फ डायरेक्शन से फर्क पड़ता है ना, उसको थोड़ी समझना है ज्योग्राफी. सो फॉर आवर अंडरस्टैंडिंग वी हैव नेम्ड इट एज नॉर्थ पोल. इनसाइड द अर्थ इट इज द साउथ पोल ऑफ बार मैग्नेट, एंड दैट्स व्हाई द मैग्नेटिक फील्ड डायरेक्शन इज ऑल्सो शोन लाइक दिस. फील्ड लाइन्स, दे विल एमर्ज फ्रॉम नॉर्थ पोल and they will come back to south pole. Direction देखिए. All right, first thing. Second thing, these poles are not constant and they are not overlapping with geographical poles. Geographical poles are basically those places through which our axis of rotation passes, and not necessarily they will overlap with magnetic poles. Okay, they can be away from each other. Rather, we can say that north magnetic pole is continuously shifting at present from north of Canada towards the Siberia. In last 200 years, it has considerably shifted from north of Canada towards the Siberia, Russia के north में. Okay, and in past also these poles have wandered. Even they have reached to near equator in past. आप सोच रहे होगे इक्वेटर पे पोल, we are talking about magnetic poles. Okay, we are not talking about geographical poles. राइट. इक्वेटर तो हमें जोग्राफिकल टर्म्स में समझ में आता है, राइट. सो डोंट गेट कंफ्यूज. नाउ सम कॉन्सेप्ट्स आर देयर. व्हाट कॉन्सेप्ट्स आर इन्वॉल्व हियर? Earth's magnetic field.
Between magnetic pole and north pole, is it of significance that?
Yes.
Diameter is given?
Yes, yes. Two concepts are important here. ठीक है, यहाँ पे जो एंगल दिया हुआ है वो एंगल क्या है? Yes, 11.5 डिग्री दिया हुआ है. ठीक है. So what is this angle? This 11.5 डिग्री एंगल?
Axis के साथ.
Yes, एक्सिस के साथ दिया हुआ है. But at center, if it is, let's say, mention that there is a hypothetical, let's say, magnetic bar or needle is placed at the center of the earth, and when it is making an angle with the geographic poles, that is called as angle of inclination. Okay, it is called as angle of inclination. There are two concepts here. Let me explain that and its significance. It can be also asked in prelims. First of all, angle of dip or angle of declination, and other is angle of inclination. What is this concept? Yes, angle of dip. क्या concept है ये? Anyone? If suppose this needle is kept like this, okay, and I am standing at equator, it will be aligned exactly parallel to the earth's surface, right, like this. Now let's say I am moving towards the pole. Look at the movement of this needle. I am moving towards the pole, and now I am at the pole. At pole, this needle is exactly perpendicular. But this will not be the case in compass, right? In compass, it will not move like vertical like this. To actually correct this error because of changes happening from equator to poles, we have angle of inclination. Now this situation arises when we are moving in plane. Why? Because this is vertical movement, right? ये क्या है? ये vertical है ना, ठीक है. तो प्लेन जो है, समझो यहाँ से उसको पोल्स की तरफ वहाँ पे उतरना है, तो वहाँ पर इसको ये एंगल समझना होगा, ठीक है, जो एंगल ऑफ इंक्लिनेशन है. नाउ द सेकंड इज एंगल ऑफ डिप. नाउ इफ सपोज शिप्स आर मूविंग टुवर्ड्स, लेट्स से नॉर्थ पोल, ठीक है, उसको नॉर्थ पोल को जाना है, बट उसको जाना है ज्योग्राफिकल नॉर्थ पोल पे ना, बट कंपास कहाँ लेके जाएगा उसको? मैग्नेटिक नॉर्थ पे लेके जाएगा ना. दिस एरर हैज टू बी एडजस्ट इन नेविगेशन. अब ये एरर कहां से आया? हॉरिजॉन्टल प्लेन में आया. ओके, दिस इज द कंपास. आइडियली आई हैव टू रीच देयर, बट इट इज टेकिंग मी हियर. This angle has to be compensated from time to time as I am moving. तो उसको बोला है angle of dip. Okay, have you understood this concept? And कहाँ पे use हो रहा है? एक हो रहा है horizontal plane में और दूसरा हो रहा है vertical plane में. Okay, applications, aeroplanes, other ships, the normal navigation. ठीक है, और वो एरर कहां पे हो रहा है, समझ रहा है क्यों हो रहा है? वन मूविंग टुवर्ड्स द पोलर रीजन, और वी कैन से दैट डायरेक्शन इज टुवर्ड्स द मैग्नेटिक पोल. एक्चुअली वी वांट टू मूव टुवर्ड्स ज्योग्राफिक पोल, एंड दैट्स व्हाई दिस चेंज. एंड वर्टिकली इट इज बिकॉज ऑफ वर्टिकल मूवमेंट इन द प्लेन, दिस नीडल, राइट. सो दिस कॉन्सेप्ट इज नॉट गिवन इन एनसीईआरटी and a little bit difficult to understand, I am telling you. ठीक है. Now next is Earth's magnetic field. It is called as Earth's magnetosphere. Okay, Earth's magnetosphere. Now before that, 2-3 important concepts. One, solar flares. Okay, what do you mean by solar flares? What do you mean by coronal mass ejections, CMEs? And what do you mean by solar storms? Okay, so first of all, let's understand solar flares. Solar flares are the activities which are related to sunspots on the sun surface, sunspots. What are sunspots? They are excessively higher magnetic field areas on the sun surface, sunspots. They are relatively cooler in terms of temperature, but they are having built up magnetic field. ठीक है, built up magnetic field means, look at this, let's say this is the rubber, and if I am stretching that rubber in this direction, now that rubber is having built up energy. If I release this rubber, suddenly there will be vibrations. Now, when that magnetic field is suddenly released from the sunspot surface, there will be solar flare, which is basically high electromagnetic radiations. वो क्या है? High electromagnetic radiations which reach on the earth surface with the speed of light. 8 मिनट के अंदर वो पहुंच जाएंगे, because they are radiations. Okay, that is solar flares. They are very harmful. Okay. Second is coronal mass ejections. Now, coronal mass ejections are related to charged plasma particles that are emitted from the corona of sun surface. Corona is basically the high temperature region on the surface of sun. Okay. And that corona is having excessively high temperature than the interior of the sun. Now again, the built up energy that can be formed at certain places on the sun, the way the boiling water is having the bubbles at certain places. Bubbles surface पे देखिए ना, boiling water पे ऐसा sun के surface पे भी ऐसे bubbles उड़ते हैं. Basically, they are CMEs, coronal mass ejections. They are charged plasma particles, but they are comparatively slower, and they reach up to 2 to 3 days from sun surface to earth surface. But these charged plasma particles are very harmful. And here the role of earth's magnetic field. ठीक है, तो जब हम solar storm बोलते हैं या geomagnetic storm बोलते हैं, so it is largely because of these two, solar flares and coronal mass ejections. Okay, and understanding and giving early warning about these two phenomenon is called as space weather. It is called as space weather. This is what we want to understand, and that's why we had launched this Aditya L1 mission. Space weather. It is related to solar storms. Okay. Now, sunspots. The sun or solar cycle is basically associated with sunspots. Solar cycle जिसको बोलते हैं, this is 11-year cycle of solar maxima and solar minima. Solar maxima experiences the higher sunspot activity, and solar minima is basically less number of sunspots on the sun's surface. So more number of sunspots means more energy is built up. There is more possibility that harmful CMEs and solar flares will be released. Okay. So that is associated with, we can say, space weather. Now, Earth's magnetic field acts as a shield against those harmful radiations and plasma particles. How it acts as a shield? Let's understand. Let's say this is the Earth's magnetic field and harmful solar winds are coming from this direction. Okay, so Earth's magnetic field will obstruct them here. It is a kind of shock to these solar winds. It is a kind of shock to the solar winds, and this is called as bow shock. This region is called as bow shock. Bow, it looks like bow and arrow shape. That's why bow shock. So these plasma particles are facing opposition, obstruction here. Now after facing obstruction, most of the particles will try to move along the boundary of this bow shock and they will try to move away from this particular magnetosphere. ठीक है, क्योंकि वहां पर उसको obstruction है, जहां पर कम obstruction है वहां पे वो flow करेगा. Now some of the high energy plasma particles still enter into Earth's magnetic field, and where they are entering, they will enter into the polar regions of the Earth, let's say surface, polar region. Why? Because they will be moving along the Earth's magnetic field lines. They will be moving along the magnetic field lines. Magnetic field lines descend where? They descend? Yes, they descend near the poles, or they emerge from the poles, and that's why they are largely entering in this region, forming this kind of shape. This is called as polar cusp, CUSP. It is called as polar cusp. Look at this, it is a kind of funnel shape. Now, when there is very strong solar wind, the Earth's magnetic field is disturbed. Okay, its shape is disturbed, and that is basically called as geomagnetic storm. When there is strong solar winds, they are disturbing Earth's magnetic field, that creates strong geomagnetic storms. Okay, geomagnetic storm is related to the changes happening inside the Earth's magnetic field because of these charged particles. Now that is very harmful. How it is harmful? These descending charged particles, first of all, they are forming the auroras there. तो वो तो अच्छी बात है, दिखने में अच्छा लगता है, right? What are these? Northern lights, aurora borealis, and southern hemisphere में aurora australis. So how they are formed? These charged particles, they are descending up to the lower atmosphere like stratosphere, mesosphere and stratosphere, and there the oxygen, nitrogen, these gases are there. They are interacting with these gaseous particles and making them excited. In their excited form, they release the energy, and that result into formation of lights. They release photons, they release energy, and that's why they are, let's say, illuminated. The sky is illuminated because of this, and different colors are due to different gases, interaction with different gases. The green light, red light, ऐसे अलग अलग lights दिखते हैं. Okay, now if it is very strong, the aurora formation can be seen even in lower latitudes. Why? Because more and more charged particles are entering into atmosphere. Okay, if it is very strong geomagnetic storm, it can be seen even in lower latitudes, like even in US, northern part of US. ऐसा बोलते हैं कि लद्दाख से भी दिखा है हमारे यहाँ से. लद्दाख से दिखने का रीज़न ये भी हो सकता है कि वहाँ पर मिनिमम लाइट पोल्यूशन है. ठीक है, तो लाइट पोल्यूशन कम है तो हमें बहुत सारे सेलेस्टियल फेनोमेनॉन दिखते हैं. ठीक है, दैट्स व्हाई वी हैव ऑब्जर्वेटरीज देयर. इंडियाज फर्स्ट डार्क स्काई रिजर्व एंड ऑल दिस थिंग्स आर देयर. हैनले विलेज वहीं पे है, राइट? सो दिस फेनोमेनन. नाउ व्हाई वी आर सेइंग हार्मफुल? बिकॉज दैट रिजल्ट इनटू, yes, they can damage the satellites and they are working.
Migratory species को कर सकते हैं.
Yes, it will affect the migratory species, migratory birds or marine animals. Why? Because they are dependent on the
Earth's magnetic field.
yes, magnetic field lines. Okay, and when they are changing, they will change their path. It is also going to affect the astronauts doing the spacewalk. Okay, it is going to affect the GPS, right, global positioning system, or microwave or radio communication system, or it will also affect the power lines, right? So it may result into power cuts because long cables, it is going to affect the long cables because that that is having magnetic field around it. मैंने अभी बताया ना कि it is going to produce magnetic field around it. So those changes in the Earth's magnetic field will affect that electric lines or electric supply, power lines. So that's why there can be power failures. That's why the countries located in the higher latitude, when they receive any warning related to geomagnetic storm, they themselves shut down the power. ठीक है, ताकि कोई लॉस ना हो जाए, एक्सीडेंट ना हो जाए. So these are the impacts. Already UPSC has asked question on this. ठीक है, तो ज़्यादा कोई ये नहीं है. हाँ, रिसेंटली एक ये न्यूज़ में था, वैन एलन बेल्ट, रेडिएशन बेल्ट. हाँ.
So solar winds and coronal mass ejections both cause auroras, or it's only coronal mass ejections?
Coronal mass ejections, plasma particles,
Not solar winds, because that is only radiation.
radiation. Okay, that is harmful radiation, and let's say more UV rays, they are harmful, no, they reach on the earth. That can be problematic. ठीक है? Okay. Now, what I was telling you is Van Allen radiation belt. So, this is related to polar region, but what happens in near the equatorial region? You can see here there is shock. So, they are descending near the pole, but some of the particles are basically entering this region and they are stored by the earth magnetic field in this region. These charged particles are stored and slowly released later on. They are slowly released later on outside. This is called as Van Allen radiation belt. ठीक है? Recently, why it was in news? There was one space launch wherein the private members, non-astronauts, they entered into space. क्या था वो? 100 किलोमीटर तक पहुंचे हैं ना अभी. अमेज़न का था, किसका था? स्पेसएक्स का था, अमेज़न का था. तो वो फाउंडर भी बैठा था ना उसमें, कोई तो एक उनका, जेफ बेजोस, वो बैठा था उसमें. एंड दे हैव रीच्ड टू 100 किलोमीटर and they entered into that Van Allen radiation belt to understand the impact of that radiation and charged particles on human body. वो एक उसका ऑब्जेक्टिव था. तो ये न्यूज़ में था, Van Allen radiation belt. Okay, fine. All right. Now next, ये ऑरोरा फॉर्मेशन ऐसे दिखता है, ये हमने अभी पढ़ा है. All right, geomorphic movements, quickly we will go through that. ठीक है, थोड़ा सा टाइमिंग आपको 5 बजे का बोला हुआ है, but it can extend it to 5:30. ठीक है, 5:30 तक हो जाएगा एक्सटेंड. हाँ,
ये थोड़ा पहले भी हो सकता है क्योंकि मेरी 5 PM से दूसरी क्लास है.
अच्छा, ठीक है, विल आस्क देम टू शिफ्ट. 2:30 से करने से कोई प्रॉब्लम है किसी को? 2:30 इज फाइन, राइट? एवरीवन? Because some topics will be extended, some topics will be covered in time. ठीक है, हमें MCQs भी प्रैक्टिस करना है, वो मेन है, इम्पॉर्टेंट है. ठीक है, सो आई गेस दिस इज नॉट दैट मच प्रॉब्लम. ठीक है, जल्दी हो जाएगा इसमें. एंडोजेनिक एंड एक्सोजेनिक मूवमेंट्स. सो एंडोजेनिक मूवमेंट्स, दे आर ओरिजिनेटिंग फ्रॉम विद इन द अर्थ and exogenating from outside the earth. The main source of energy for this one is solar energy. The main source of energy, it is basically the heat energy inside the earth. Endogenic force. Endogenic processes can be divided, or movements can be divided into two parts, diastrophic and catastrophic. Diastrophic means slower. Okay, they are slow movements, and catastrophic is sudden movement. So sudden movements can be observed in phenomenon like earthquake, volcano. So they are sudden movement. While diastrophism, it can be further divided into epirogenic or continent building movements and orogenic or mountain building movements. Okay, oro means mountain, epiro means continent. Now when we talk about continent building, either there will be upward or downward movement, that is towards or away from the center of the earth. Towards or away from the center of the earth, upward or downward movement, continent building. Large landmass will move up or down. Okay, now here orogenic means mountain building processes largely they are tensional or compressional forces. So that means when the rocks are moving towards each other, there will be formation of fold mountains. When they are moving away from each other, there will be formation of block mountains. This year's question, match the following. Tha na question? So Alps mountains they had mentioned, Vosges mountains they have mentioned. It is from basic NCERT. Alps are fold mountains, Vosges mountains are block mountains, Vindhyas are block mountains. ठीक है? So fold mountains और block mountains में difference क्या है? Block mountains are formed largely through tensional forces away from, while the fold mountains are formed through compressional forces. तो ये उसमें difference है. And exogenic processes, largely they are three types of processes. It is weathering, mass movement and erosion. Mass movement लिखा नहीं है इसमें, but it is there. Mass movement will learn landslide, rock slide और avalanche. तो ये सारा क्या है? Mass movement. Weathering, physical, chemical, biological, three types. Erosion. So tomorrow we have separate session on this. ठीक है? NCERT का सबसे बड़ा chapter. We are going to cover it separately. The different landforms that are formed by all these agents of erosion. ठीक है? But quickly we will see the remaining parts. ठीक है? Tectonic theory. Okay. So continental drift theory, sea floor spreading and plate tectonic theory. ये तीन theories है. Already UPSC has asked question multiple times on these theories. Even in mains examination, question has been asked on Wegener theory, continental drift theory, plate tectonic theory. ये रह गया है, आज न कल ये भी पूछ लेंगे. ठीक है? Sea floor spreading. So first of all, it is the continental drift theory. So you tell me, it was given by Wegener, right? So what he said, first of all, there was a large landmass called as Pangea. All land masses were united in the large single landmass called as Pangea, and the remaining water body surrounded it called as Panthalassa. So around 250 million years ago, that Pangea broke into two land masses called as Laurasia and Gondwana land. Now that Laurasia and Gondwana land, in between them there was formation of Tethys Sea. Further, these land masses broke into several land masses and they drifted away from each other. This is how he is explaining the present day distribution of land and ocean. All these tectonic theories are explaining present day distribution of land and ocean. ठीक है? So he is giving two forces in support of, we can say, first of all we will see the forces. ठीक है? What forces he had mentioned? He first gave pole fleeing force or buoyancy. Pole fleeing force. So, or polar fleeing force. What do you understand by this? The land masses are fleeing the poles and moving towards the equator, largely because of buoyancy and rotation of earth. So let's imagine that all these land masses are floating on the water. Imagine. And if the body is moving or rotating, what will happen to the, let's say, solid parts? They will be moving away from the axis because of centrifugal force. And when they are moving away from, away from the axis, they will move from pole towards the equator. Basically, this is polar fleeing force. अब देखिए, ये आपको शायद फाउंडेशन बैच में ऐसे एक्सप्लेन नहीं किया होगा कि क्या था ये पोलर फ्लिंग फोर्स. इमेजिन हो रहा है ये कि सॉलिड कहां जाएगा, सेंट्रीफ्यूगल फोर्स की वजह से ये टुवर्ड्स इक्वेटर जाएगा. buoyancy. Then that's why most of the continents, including Indian plate, it moved towards the equator. African continent, it moves towards the equator, right? Now, tidal force, second force, this was giving westward movement to the continents. ठीक है, ये क्या था, इक्वेटर वर्ड, टुवर्ड्स इक्वेटर. This was westward. Tidal, in terms of geography, tidal force is basically gravitational force of attraction among different celestial bodies. उसको tidal force बोलते हैं. ठीक है, ये क्लासिकल टर्म है. ठीक है, टाइड्स वाला वो कॉन्सेप्ट यहाँ नहीं है. टाइड्स जो है हम बोलते हैं ओशन की वजह से जो टाइड्स होते हैं, बट द रूट कॉज फॉर दोस टाइड्स इज ऑल्सो force of attraction, gravitational force of attraction. Basically that is called as tidal force. Okay, so here also by tidal force he is meaning the force of attraction by moon and sun, and he is saying that the continents are moving towards west, like the southern America broke from Gondwana land and moved towards west. North America broke from Angara land or simply Laurasia, move towards the west. तो ये उन्होंने forces बताए, although he was criticized on these forces only. Why? Because it was found that they are inadequate forces to move such large land masses on the earth. अब उन्होंने क्या किया है, उन्होंने दिए हैं evidences. This was largely promising. Okay, forces से ज़्यादा evidences promising लग रहे थे, इसलिए ये एक्सेप्ट की गई थी थ्योरी. ठीक है, सो एविडेंसेस, मैचिंग ऑफ कॉन्टिनेंट, जिग्स ऑफ इट, लाइक दिस वन, लुक एट दिस, मैचिंग ऑफ कॉन्टिनेंट्स, जिग्स ऑफ इट, exactly matching all the coastlines. So that's why it was felt that sometime in the past they may be part of larger one continent or larger land body. Second, placer deposits of Ghana and Brazil. So it has been found the placer deposits in Ghana, gold deposits, but the source rock is located in Brazil. ठीक है, तो इसलिए ऐसा बोलते हैं कि ये कहीं ना कहीं ब्राजील यहाँ पर था और फिर ये डिपॉजिट्स बने हैं, फिर ब्राजील चला गया. ठीक है, then distribution of fossils, plants and animals, like Glossopteris is one of the, let's say, aquatic plant, and its fossils are found in all continents of Gondwana land. Or the animals like marsupials or Mesosaurus, ये देखिए Mesosaurus, it is found in these continents, or fossil fuels of a reptile called as Lestrosaurus. So from that also we understand that they were once together, or we can say that continent. Then other, let's say, evidences are also there. For example, tillite deposit. Tillites are basically glacial deposits, glacial sediments. In India also, in Karnataka, tillite deposits are there. So how can Karnataka have glacial deposits? So in geological past, either during glacial age or ice age, ice must have been there in Karnataka, or this continent itself, landmass itself must have been in polar region. दो रीजन हो सकते हैं. तो पहला तो पॉसिबिलिटी नहीं है ना, ट्रॉपिकल एरियाज में भी आइस एज में ग्लेशिएशन नहीं था. ठीक है, इतना एक्सटेंसिव ग्लेशिएशन नहीं था कि वो ट्रॉपिकल एरिया में भी ग्लेशिएशन करे आइस एज में. ओके, एंड दैट्स व्हाई दैट possibility is ruled out. That's why second possibility, that Indian landmass, peninsular landmass, moved from polar region to the present day equatorial region. So that is accepted, we can say that movement of continents. Okay, so this is continental drift theory. Second we can talk about is sea floor spreading hypothesis. This hypothesis was given based on two important concepts. One is the theory of convection current. Okay, convection current theory was given by Arthur Holmes. So according to this theory, there is movement of magmatic currents. They are called as convection currents inside the asthenosphere. Now, why these are moving in the circular manner or a kind of currents? Anyone? Very good. It is because of temperature differences, thermal differences, and they are moving from one place to other place. And that is resulting into, we can say that, movement of magma in a kind of cyclic manner. Okay, so that is called as thermal convection current, and it was given by Arthur Holmes first. Second, the post Second World War expeditions, sea floor expeditions, whatever the observation they had made in that expeditions, what were the observation? First observation क्या था? There is extensive volcanic eruption happening along the mid-oceanic ridge region. First observation. Second observation regarding the magnetic properties of rocks So the rocks which are near the mid-oceanic ridge region, they showed the normal polarity. But when they are away from the mid-oceanic ridge, so they are showing the reverse polarity, the older age. Also the age of rocks. So it has been found that the age of rocks near the mid-oceanic ridge, they are younger, and as we move away, they are older. Also it has been found that nowhere in the ocean floor the oceanic rocks are older than 200 million years old. That means somewhere they are being consumed also. ठीक है, तो कहीं ना कहीं डिस्ट्रक्शन भी हो रहा है, and that destruction was happening in the trench region. Fourth earthquake, it has been found that the deep seated or deep focus earthquakes were happening in the trench region and shallow focus earthquake were happening in the mid oceanic ridge region. ठीक है, so these findings and the convection current theory has led to proposal of sea floor spreading hypothesis by Harry Hess, Professor Harry Hess. He gave this theory. So according to this theory, what is happening along the mid-oceanic ridge region, there is continuous magma coming up through weak zone, and there is formation of new oceanic crust along the mid-oceanic ridge, and the magmatic currents which are flowing beneath that oceanic crust are basically dragging this new crust form in two directions. It is dragging, okay, and because of that the crust is moving in this direction, and this is trench, this is continental plate, this is oceanic plate. So here in trench what is happening? Oceanic crust is subducting. Why? Oceanic crust is denser than the continental crust. अभी हमने पढ़ा है. So denser will subduct, and because of that it will move to the deeper levels. When it reaches up to 100 km, the temperatures are hot enough, warm enough to melt down that oceanic crust, rocks, into magma. So they are getting added into magmatic currents again. ठीक है, तो ये देखिए फिर से ये करंट में ऐड होते जा रहा है. This is how these currents are moving in asthenosphere, and the sea floor is spreading. But it has been found that it is not spreading at the faster rate, the rate at which the new magma is formed at mid-oceanic ridge region. That means somewhere the older crust is getting consumed near trench region, and that's why it is not expanding at faster rate. And it is also found that let's say in other parts of the world the continental crust is not being consumed. जहाँ पे एक जगह पे अगर बढ़ रहा है तो कहीं से कंज्यूम भी तो होना चाहिए. So it was being consumed near the trench region. Okay. Now if there is rate of formation of new crust is more than rate of consumption of older crust, then we will say that sea floor is expanding. Like for example, Atlantic Ocean. In Atlantic Ocean what is happening? The sea floor is expanding continuously because rate of formation of new crust is more than rate of. ठीक है. Now you have understood this. Okay. Next, plate tectonic theory. So it was given by Mackenzie and Morgan. Basically all these theories now are based on the idea that all the continents are flowing in the horizontal direction. They are moving in the horizontal direction. But the force which is responsible, now the force has been accepted as convection current theory or convection currents of magma. Now according to plate tectonic theory, it is not the continents which are floating on the asthenosphere, rather it is the lithospheric plates. ठीक है, इससे पहले ये चीज किसी ने नहीं बोली है. इससे पहले जैसे कि वेजनर क्या बोलता है, वेजनर सेज दैट Sial floats over Saima. According to him, continents floats over oceanic crust, but that was negated later on. Okay, so here the concept of lithospheric plate was given, and these lithospheric plates are floating on liquid asthenosphere. Okay, it is floating or freely moving on liquid asthenosphere, and the underlying magmatic currents are giving direction to these plates. And accordingly three types of boundaries are formed. There are major plates as well as minor plates. Major plates कौन से हैं? Pacific plate, which is largely oceanic plate. Eurasian plate, which is largely continental plate. Then we have North American plate, South American plate, African plate, and Antarctic plate is also there, and then Indo-Australian plate. Then there are several minor plates. ठीक है, माइनर प्लेट्स का एग्जांपल आप देखिए. हाँ, यहाँ पे देखिए कोकोस प्लेट किस में है, पैसिफिक और नॉर्थ अमेरिका में है और सेंट्रल अमेरिका. नास्का प्लेट इज बिटवीन पैसिफिक प्लेट एंड साउथ अमेरिका. अरेबियन प्लेट इज देयर, फिलिपाइन प्लेट इज देयर, formation of Philippine Islands, formation of Indonesian Islands. This is because of interaction. 3 types of plates. Divergent plate boundary is basically at mid-oceanic ridge region. Formation of new sea floor, ocean floor. It was constructive. Why? Because new magma is coming up and new crust is being formed. तो इसीलिए इसको constructive बोला गया है. And it is also having ridge or rift like this. ठीक है, the way we are having the rift getting expanded in East Africa, it is called as East African rift. आपने recently पढ़ा होगा न्यूज में अफार ट्रायंगल. It is going to be the new ocean in future. ठीक है, so basically because of the underlying magmatic currents are diverging and ऐसा बोला जाता है कि नीचे बहुत बड़ा एक mantle plume है. किसके नीचे? ईस्ट अफ्रीकन फॉल्ट के नीचे. ठीक है, वहां पर क्या है, मेंटल प्लूम है, एंड दैट इज बेसिकली लेट्स से फोर्सिंग द अफ्रीकन प्लेट, लार्ज अफ्रीकन प्लेट टू डिवाइड इनटू 2 पार्ट्स. ऑल राइट, कॉन्वर्जेंट प्लेट बाउंड्री, वेयर द 2 plates are converging, the denser one will subduct under the lighter one and there will be formation of subduction zone which is also called as Benioff zone. ठीक है, तो उसको डिस्ट्रक्टिव बोला गया है बिकॉज द क्रस्ट इज कंज्यूम्ड हियर. राइट नाउ मोस्ट ऑफ द वोल्केनोज एंड टेक्टोनिक एक्टिविटी हैपन्स अलोंग दिस बाउंड्री. पैसिफिक रिम ऑफ फायर, ठीक है, रिंग ऑफ फायर जिसको बोलते हैं, इट इज बेसिकली दिस रीजन, सर्कम पैसिफिक जोन. ओके, एंड हियर ट्रांसफॉर्म बाउंड्रीज, हियर देयर इज स्लाइडिंग पास्ट ईच अदर. Now majority of transform boundaries can be found along the mid-oceanic ridge region and they are perpendicular to the mid-oceanic ridge. Why it is like that? Transform boundaries largely found along the mid-oceanic ridge region and they are perpendicular to mid-oceanic ridge. Let's say this is mid-oceanic ridge. This is how transform boundaries are formed. ऐसा क्यों तैयार हुआ है? Because actually this is not the way boundary look like. It looks like this. Why? It's not one line. It is like fragmented, and that's why we have these transform boundaries form here like this. They are perpendicular to mid-oceanic ridge. Why? Because the rocks which are formed here through volcanic eruption, their movement in this direction and this direction is different than this movement and speed. Because of that, there is transform boundary formed between these rocks and these rocks, these rocks and these rocks, because they are moving parallel to each other at different speed. That is why transform boundary is formed there. अंडरस्टूड? समझ में आया है ट्रांसफॉर्म बाउंड्री कैसे तैयार हुआ है? ओके, नाउ क्विकली विल सी द नेक्स्ट पार्ट. छोटा सा ही है, ठीक है. मूवमेंट ऑफ इंडियन प्लेट, इट इज गिवन इन एनसीईआरटी. ओके, सो दिस इंडियन प्लेट स्टार्टेड मूविंग लाइक दिस 71 मिलियन ईयर्स एगो. फॉर्मेशन ऑफ हिमालयाज हम वो अलग से पढ़ेंगे अपकमिंग लेक्चर्स में कहीं तो, ठीक है. हिमालयाज कैसे तैयार होता है अलग से, ठीक है. तो ये हो गया आपका. चलिए आप क्वेश्चन सॉल्व करते हैं क्विकली, ठीक है. प्रैक्टिस क्वेश्चंस देखिए, ज़्यादा टाइम नहीं लगेगा. आंसर्स बताइए. ऑनलाइन स्टूडेंट्स, यू कैन ऑल्सो मेंशन योर आंसर इन द कमेंट बॉक्स. क्वेश्चन नंबर और आंसर लिखिए ताकि हम भी, ठीक है. मेंशन द क्वेश्चन नंबर एंड आंसर. यस, बताइए आंसर. How many of the above activities are categorized under diastrophic movements? Only one. Yes, it is only one. Landslides are also catastrophic. The movements which are observable through naked eye, they are catastrophic. Okay, the movements which are observable through naked eye, हमें दिख रहा है कि मूव हो रहा है, they are catastrophic basically. ठीक है, बाकी के अर्थ मूवमेंट जो होता है, माउंटेन बिल्डिंग और ये, इट्स वेरी डिफिकल्ट. सो इट्स ओनली वन. ठीक है, डायस्ट्रॉफिक जो है, इट इज माउंटेन बिल्डिंग, वी कैन से दैट. हाँ, ओनली वन. ए इज द करेक्ट आंसर. व्हाट अबाउट दिस वन? Acidic lava and basic lava. In volcanism we learn about this. क्या होना चाहिए? Acidic lava is rich in metallic minerals and has low melting point.
Basic is rich in metallic.
Yes, and it is having, acidic lava is having very high melting point. That's why it is viscous. That's why it is viscous. Remember the property. एक property याद रखनी है सिर्फ. It is viscous and it is fluid. Acidic lava is highly viscous. Okay, and explosive volcanoes. ठीक है, जो सिंडर कोन नहीं, क्या बोलते हैं हम उसको, स्ट्रेटो वोल्केनोस जिसको बोलते हैं. ठीक है, विशुवियस वोल्केनोस और स्ट्रेटो वोल्केनोस और कंपोजिट वोल्केनोस. बेसिक लावा इज इरप्टेड थ्रू शील्ड वोल्केनोस or flood basalt provinces, mid oceanic ridge region. So C is the correct answer here. Now what about this one? न्यूज में थे ये पिछले साल. माउंट मेरापी कहाँ पर है? इट्स इन इंडोनेशिया. माउंट मेरापी हैज बीन इरप्टिंग कंटिन्यूअसली. देन दिस इज पोपाकैपिटल वोल्केनो इज इन मैक्सिको. ठीक है, इट इज लोकेटेड इन मैक्सिको along the Gulf of Mexico, that region. And Tonga, नाम में ही टोंगा है. ठीक है, टोंगा आइलैंड इज देयर इन पैसिफिक, वहां पर इरप्शन होता है. ऑल थ्री आर करेक्ट. व्हाट अबाउट दिस वन? इंट्रूसिव रॉक्स, वेरी सिंपल. डिफरेंट फॉर्म्स ऑफ इंट्रूसिव रॉक्स आर देयर. Yes. What are sills? Sills are basically horizontal movement of solidification of magma. ठीक है, straight line में जो होता है horizontal. So horizontal igneous rocks, that is true. Batholiths, what are batholiths? They are the large magma chamber, solidified, deep granitic rocks are formed from them. So very large granitic bodies, correct है. Lapoliths, lap, मैंने बताया था लैप ऐसे होता है, लैप की तरह. कॉन्केव टूवर्ड्स द फेस, सॉरी स्काई, कॉन्केव टूवर्ड्स द स्काई. सो सिंपली इट इज कॉन्केव शेप्ड. फैकोलिथ्स, यस. सो व्हेनेवर देयर आर compressed rocks, so in a horizontal direction the magma is solidifying at the top of anticline and the bottom of syncline. So they are the wavy masses, wavy intrusive rocks, fagoliths. And what are laccoliths? Convex dome shape with conduit from bottom. So all are correctly matched. D is the correct answer. What about this one? This is given in GC Leong. NCERT में नहीं है geysers और hot springs. Right. Geysers are fountains of hot water where water is emitted with an explosion. Okay, that is true. Water भी होता है और gas भी होता है, दोनों. That's why the gas, because of gas only there is explosive aspect is there. Water तो होता ही है ना. Hot springs are very common to be found and water rises in them without any explosion. That is also true. Comparatively common we are saying with geysers. Okay, common means comparatively geysers से common है. Geysers are largely found in the volcanic regions, right? But hot springs can be found anywhere. Okay. So both are correct here again with reference to natrocarbonate कार्बोनेटाइट लावा. क्या होता है ये लावा? एक्चुअली ये न्यूज में था इसलिए हम कवर कर रहे हैं. क्या होता है ये लावा?
बेसिक टाइप ऑफ लावा.
हाँ, बेसिक टाइप का होता है. और see, this is very rare kind of lava having very low melting point. Okay, it is very low melting point and we can say it is relatively cooler than other type of lavas. Okay, it is relatively cooler than other type of lavas. It is so cool that it is basically let's say black in color. Okay, it is black in color and it is very unique. We can say why? Because it is only erupted in one of the volcano in Tanzania. उसका नाम है ओल्दाइनो लेंगाई. ओल्दाइनो लेंगाई, OLDOINYO LENGAI, ऐसे 3 वर्ड्स है. टांजानिया में ईस्ट अफ्रीकन रिफ्ट में जो वोल्केनिक इरप्शन होता है, सिर्फ रिमेंबर टांजानिया. ओके, ईस्ट अफ्रीकन रिफ्ट. So this type of lava is found only there. It is rare kind of, we can say, lava. In terms of composition, see, most of the lavas are rich in silicate minerals, but this type of lava is rich in sodium and potassium carbonate minerals. And due to its unusual composition, the lava is erupted at relatively low temperatures. It is so low that molten lava appears black in sunlight rather than having red glow common to most of the lavas. And it is also much more fluid than silicate lavas. अब देखिए, ये तो सही है. थर्ड वन, हाई विस्कोसिटी ड्यू टू लैक ऑफ सिलिका, ऐसे बोल रहा है. कॉन्ट्राडिक्टरी है. पहला क्या बोल रहा है? इट इज रिलेटिवली कूलर. तो ये 2 स्टेटमेंट सही है, फर्स्ट एंड थर्ड. So only 2 is the correct answer. What about this one? न्यूज में था ये. लेक, वर्ल्ड्स मोस्ट एसिडिक लेक. यस, कौन सा है ये? इंडोनेशिया में लोकेटेड है. इट इज लेक कावालजन. ठीक है, इसका स्पेलिंग ऐसे है. कावालजन. Okay, it is located in Indonesia. So it is a kind of crater lake in one of the volcano, and that is having more acidic, let's say, emissions. Gaseous emissions are happening from that. Most acidic and flammable sulfurous gas is emitted there. Okay, Lake Kavaljan. What about this one? Very simple one. Volcanic lakes are commonly found in Indonesia. Yes, crater lakes, जहाँ जहाँ volcanoes है, crater lakes है. And Indonesia is located over the divergent plate boundaries, convergent plate boundaries, right? They are formed due to ocean-ocean convergence, ocean-ocean plate convergence, right? Sunda shelf or Sunda plate converging with Indo-Australian plate. So we learn that in mains examination also. ठीक है, तो सेकंड स्टेटमेंट इनकरेक्ट है, तो आंसर सी हो जाएगा. व्हाट अबाउट दिस वन? अगेन वेरी सिंपल. एक्सट्रूसिव रॉक्स, they are formed when the lava is solidified on the surface. So when it is coming on the surface, it is suddenly cooling, and because of that there will be fine grains formation, sudden cooling. So first statement is correct. While the intrusive rocks, they are deeper ones, granite. So they are slowly cooled, and that's why there are coarse grains. ठीक है, extrusive rocks form over much longer duration of time compared to intrusive rocks. That is incorrect. ठीक है, उल्टा है इसमें. तो only one, A is the correct answer. What about this one? Indirect sources. Yes, C is the correct answer. Indirect sources. So one group you have to identify. Then what about this one? I told you they will give us such kind of statements. Okay. So volume of core is more as compared to mantle. Incorrect, right? Yes. And density of mantle is more as compared to crust. That is true.
So the crust is solid and mantle is liquid. Then how can we say that the...
See, certain part of mantle is liquid. Otherwise, most of the mantle is solid. Asthenosphere part is liquid. Otherwise, most of the part, and it is very huge part. Okay, that is solid. What about this one? About comparison between oceanic and continental crust. Ocean crust are older than continental crust? Incorrect, no? Wrong. Ocean crust rocks are denser than continental crust? That is true. So 2 only. What about this one? Continental crust is thicker than oceanic crust. That is true. Continental crust thick होता है. Mantle extends until Moho's discontinuity. Gutenberg discontinuity तक extend हो रहा है ना. Mantle core boundary we have to understand here. Then crust and uppermost part of the mantle is called asthenosphere. It is lithosphere. Very simple. Outer core is solid in state. It is liquid in state. ठीक है, तो second and third it is incorrect. वहां पर incorrect पूछा है, not correct. ये देखिए command. ठीक है, not correct पूछा है. So continental crust is thicker. 1, 2, 3. Only 3 are incorrect. ठीक है. What about this one? Types of rocks: sedimentary, metamorphic, igneous rocks. Examples: rocks chapter in 11th standard NCERT. Prepare it thoroughly. छोटा सा chapter है 4 pages का, but examples and minerals. ठीक है, जो starting में एक box में minerals दिया हुआ है first page पे, उसका composition and application वो पढ़ लेना है एक बार. ठीक है. Yes, metamorphic rocks. Sandstone is sedimentary rocks. Shale is also sedimentary rock. Shale gas जो होता है shale rock में. Slate is formed from shale only. Okay, slate and schist are formed from shale only. तो दोनों metamorphic rocks है. Slate and schist. Okay, so only 2 is the correct answer. What about this one? Continental drift theory of Wegener. Which of the following are forces? Tidal and pole flowing. 2 and 3. ठीक है, 2 and 3. D only answer. What about this one? Formation of Philippine Islands and Caribbean Islands. Ocean convergence. ठीक है, ocean convergence. In Caribbean Islands, what is happening? Caribbean plate is interacting with North American plate, and that's why Greater Antilles are formed. Caribbean Islands are formed as a group of Greater Antilles, Lesser Antilles and Bahamas. ठीक है, north of Greater Antilles there are Bahamas. ये 3 मिलके पूरा Caribbean बनता है. Caribbean plate is interacting with the North American plate. It was earlier converging with each other, and there was formation of Greater Antilles like Cuba. Those small islands are there. Rather, they are bigger islands comparatively. At present, this boundary is transform boundary. And because I am repeating, in past this was convergent plate boundary that led to formation of these islands. But at present, this boundary is transform boundary. They are not now converging with each other. Rather, the plate is now converging from its eastern and southern side with the South American plate to form Lesser Antilles like Puerto Rico trench. Most of the volcanic eruption happens, or tectonically active region is that Eastern Caribbean region, जहाँ पर क्या बोलते हैं हम Lesser Antilles, छोटे छोटे आइलैंड्स है बहुत सारे. ठीक है, तो ये आप एटलस में देखेंगे. कल से एटलस लेके आना है. ठीक है, एवरीवन. ओके, सो ओशन कन्वर्जेंस बताइए. सिमिलर टू साउंड वेव्स, स्ट्रेचिंग एंड स्क्वीजिंग, डायरेक्शन ऑफ वाइब्रेशन परपेंडिकुलर नहीं है, इन द डायरेक्शन है, परपेंडिकुलर नहीं है. सो ओनली 2. यस, व्हाट अबाउट दिस टाइप्स ऑफ वोल्केनोज? In description type of question, let me give you hint. Identify any key information, key word from the description and try to eliminate the options. Try to eliminate the options. Like these volcanoes are characterized by eruption of cooler and more viscous. More viscous बोला है, shield volcano और flood basalt मैंने remove कर दिया क्योंकि वो fluid है. I have eliminated that. Then these volcanoes often result in explosive volcanoes. It can be caldera or composite. Still confusion. Along with lava, large quantities of pyroclastic material ashes leaves the ground. The material accumulates in the vicinities, opening leading to formation of layers. Formation of layers is stratovolcano or composite kind of. तो देखिए हमें की इंफॉर्मेशन समझनी है और एलिमिनेशन करते चलना है. ओके, देन discontinuities, very simple one. Lehmann discontinuity between inner core and outer core, that is true. Then Gutenberg discontinuity between mantle and core, तो incorrect है ये. Then Moho discontinuity between crust and mantle, it is incorrect. So only one is correct here. What about this one? How many of the above phenomena are observed at the mid-oceanic ridge? Yes? Only 3. Deep focus earthquake नहीं होता है, shallow focus earthquake होता है, right? Deep focus earthquake trench के यहाँ होता है. Then formation of new crust, that is true. Formation of islands, that is also true. Okay, many islands are formed. Why? Because that volcanic eruption may result into formation of islands that may reach above the sea surface. Then divergent movement of plate, that is true. Which of the following evidences was not in support of? Not बोला गया है. Yes, distribution of fossils was evidence in continental drift theory. Right? It was continental drift theory. What about this one? Water rises to without any explosion. Water may contain some minerals of medical value. ये क्या होता है? What? हाँ, hot springs में होता है ना ऐसे. Right? That's why we have all the temples wherever there is a hot spring. India में. And then we say that there are magical healing values there. उसमें तो भगवान करता है हम बोलते हैं, बट उसमें पहले से ही डिजॉल्व मिनरल्स होते हैं, राइट? सो इट इज वी कैन से हॉट स्प्रिंग्स. व्हाट अबाउट दिस वन? यस, नॉट द प्रॉपर्टी ऑफ बेसिक लावा. यस, इट कॉजेस एक्सप्लोजिव वोल्केनिक इरप्शन. नो, देयर इज साइलेंट इरप्शन. ठीक है, देयर इज साइलेंट इरप्शन इन बेसिक लावा. In acidic lava, which is more viscous, there is explosive eruption. What about this one? Shield volcano, there is formation of cinder cone. ठीक है, there is formation of cinder cone by the shield volcanoes like Hawaiian volcanoes, Mauna Kea, Mauna Kea. ठीक है, तो Hawaiian volcanoes जो है वहां पर क्या होता है? cinder cone तैयार होता है. Then composite volcanoes, layers formation. Caldera is so violent it collapses on itself. ठीक है, तो वो क्या होता है? कोलैप्स डिप्रेशन होता है. तो क्या आंसर है इसका? डी, बी फॉर बॉम्बे. ओके, ठीक है. व्हाट अबाउट दिस वन? व्हाई इट इज वायलेंट और एक्सप्लोजिव? सर्टन वोल्केनोज. नाउ दिस इज गिवन इन एनसीईआरटी. Magma chamber supplying the lava is located close to the surface. That's why caldera, volcanic, let's say explosion. Source of magma is very near to the mouth. ठीक है, so that's why volcano. If water gets into the vent, yes, that is also true. Tonga, जो वोल्केनिक इरप्शन होता है, हाईली एक्सप्लोजिव. व्हाई? बिकॉज वाटर इज गेटिंग एंटरिंग इनटू द वेंट. सो वाटर विल मेल्ट, सॉरी वाटर विल बी इवेपोरेटेड, गैसियस हो जाएगा, वाटर वेपर हो जाएगा, एंड दैट विल ट्राई टू एस्केप इमीडिएटली फ्रॉम दैट वेंट. दैट विल रिजल्ट इनटू एक्सप्लोजन. दोनों सही है, बोथ आर द रीजंस. हाँ, फॉर्मेशन ऑफ डेक्कन ट्रैप्स. फॉर्मेशन ऑफ डेक्कन ट्रैप्स कैसे हुआ है? Yes, it is because of hotspot volcanism, reunion hotspot. When Indian plate was moving over reunion hotspot, reunion island अभी कहां पर है? मादागास्कर के नजदीक में है, ठीक है. सो दैट इज रीयूनियन हॉटस्पॉट. वहां पर क्या है? मैंटल प्लूम है नीचे, ठीक है. तो वहां से हॉटस्पॉट वोल्केनिज्म होता है. एंड व्हेन इंडियन प्लेट मूव्ड ओवर दैट हॉटस्पॉट, देयर वाज एक्सटेंसिव वोल्केनिक इरप्शन एट दैट टाइम, रिजल्टिंग इनटू लावा that is forming layers after layers, resulting into Deccan traps. And then Indian plate moved further ahead, ठीक है, वो हॉटस्पॉट से आगे चला गया. Then that lava got cooled and there was formation of Deccan traps. Further weathering of that basaltic rocks resulted into formation of black soil. वहां पर ब्लैक सॉइल तैयार हुआ है. तो ये फेनोमेनॉन है, ठीक. फाइनली ये क्या है? Plate boundaries at spreading sites, new crust is generated. At subduction zone, crust is destroyed. Transform faults are generally perpendicular to. ये मैंने अभी concept explain किया आपको, right? They are perpendicular to the mid-oceanic ridges. All three statements are correct here. What about this one? Very good. Yes, online students. Your efforts are appreciated. Good. One I know कोकोस प्लेट. बताइए, देखिए मैं एलिमिनेशन मेथड बता रहा हूं आपको. कोकोस प्लेट अभी बताया मैंने, कहां पे था? इट वॉज बिटवीन सेंट्रल अमेरिका एंड पैसिफिक प्लेट. सेंट्रल अमेरिका एंड पैसिफिक प्लेट. वन इज करेक्ट. Here, look at this. One is correct. 1 and, but यहां पे देखिए क्या पूछा है? Incorrectly matched. Command of the question. So I will eliminate these two. It's C or D. 3 or 4, 2 and 3. I know the second one. Nazca plate. It was between Pacific and South America. Asiatic लिखा है. Incorrect. That means this should be there. 2 should be there. There is only one option. That is D. मुझे ये दो प्लेट के बारे में जानना ही नहीं है. और यूपीएससी ऐसे ही फ्रेम करता है. Adequate and sufficient knowledge is sufficient to attempt the answer. ठीक है. आप देखिए जरा, कभी ध्यान से पढ़ेंगे ना यूपीएससी के क्वेश्चन, आपका नॉलेज सफिशिएंट होता है, उसको अप्लाई करिए ठीक से. देखा है ऑप्शंस कैसे फ्रेम किए गए हैं? आपने क्या किया होगा, ये पढ़ के एकदम टेंशन आ गया आपको, ये तो मैंने पढ़ा ही नहीं, फ्यूजी प्लेट कहाँ है? तो कैरोलिन प्लेट जो है वो फिलिपाइन प्लेट के साइड वाली प्लेट है, छोटी सी एक, जो इंडियन प्लेट और फिलिपाइन की प्लेट के बीच में है, पपुआ न्यू गुनिया के नॉर्थ में. पपुआ न्यू गुनिया कहां पर है? ऑस्ट्रेलिया के नॉर्थ में है. उसके नॉर्थ में एक छोटा सा माइनर प्लेट है, वो कैरोलिन प्लेट है. एंड फुजी प्लेट इज लोकेटेड नॉर्थ ईस्ट ऑफ ऑस्ट्रेलिया. ठीक है, नॉर्थ ईस्ट ऑफ ऑस्ट्रेलिया. फुजी प्लेट माइनर प्लेट है, बट ये हमें नहीं पता है, तो भी हमने इसको सही मार्क किया है. फाइन. सो कैसा लगा आपको सेशन? हैव यू अंडरस्टूड ऑल द थिंग्स? यस एवरीवन? सी, ट्राई टू फॉलो दीज सेशंस, try to attempt these questions, revise all these things, study material at home, give test on Sunday और evaluation. उसके बाद immediately mentoring लेना है. ठीक है, I will be available here for mentoring. Bring your answer sheet with you, bring your question paper with you, and we will try to analyze कि कहाँ पे question क्यों गलत हुआ है, despite of reading, despite of revising, the thought process that we applied, no, we will try to change that thought process now. ये बहुत ज़रूरी हो गया है प्रीलिम्स के लिए. नॉलेज वी हैव रीच टू सर्टन लेवल ना, ठीक है, वो सफिशिएंट है एक तरीके से, बट सॉल्विंग एमसीक्यूज करेक्टली इज नाउ वी हैव टू इम्प्रूव. ओके फाइन, ओके फाइन, लेट अस स्टॉप. ओके.